Alright, this is the linear functions review, which is Unit 2 for Algebra 1 Honors. So looking at number 1, is that graph a function? And the answer is no, it is definitely not a function because it does not pass the vertical line test. And then the domain of this, even though it's not a function, it has a domain, and it looks like it goes just about, we're going to say that it goes to those lines just to make it a little bit easier. We're just past -1, and we can tell that there's 4 tick marks in between 0 and -1, so each one of those is worth a quarter. So that point right there is -1.25, and same thing on the other side. That line is +1.25. So my domain touches every single value in between there. If I can put my pencil down, I cover every x value in between those two. So my domain is -1.25 to +1.25. My range, I'm going to do the same thing, but I'm looking at the y values. And the lowest value looks like is -1, and the highest value, let's see, here was 1, and we're the next box up, so that's going to be +1.25. So my range is -1 to +1.25. And then we're going to evaluate f of 0. That means, where is my graph? Where is this heart when x is 0? So x is 0 is along this path right here. Well, it's two places. It's here at 1, and it's also down here at -1, which is why it's not a function, but it's the value of f of 0, which is really bad because it's not a function in the first place. But when x equals 0, y equals 1, and -1. Number 2, for that graph, is that graph a function? Well, yep. Yes. And it is a function because it passes the vertical line test. Remember, the vertical line test said that if I drew any vertical line, it can't touch my graph more than once. The domain for this, because we see these arrows at the two ends, the graph extends either direction forever. So it's going to be -infinity to +infinity. And my range are the possible y values. Well, I can only go up to there, but I can go down forever. So I go from -infinity, that's my lowest number, all the way up to, looks like -2 with a bracket. Remember, if we count the number, it's a bracket. If we don't count it, it's a parentheses. Then we need to evaluate that function just like the last one. So we're going to find where x is 1, which is going to be right here. Follow that down until I touch my graph, which is that point, and that gives me -4. And finally, what is the equation of that graph? Well, we've done this. We know that that's a absolute value function, which means it has the equation y equals a times the absolute value of x minus h plus k. H and k are that point right there, which is at -1, -2. And a is the slope, and it looks like the slope is, of this side, the slope is -1. So we have all the information we need. We just got to plug it in. The equation of the graph, y equals -1 times the absolute value of x plus 1, because that was my h. Or if we plug in a -1 into here, we get -1, which is +1, and then my k is -2. And just so we can see those absolute values, I'm going to put them in a different color. Alright, number 3. Which of the following represents a function? So we're looking at a table. Remember, a table is a function if all the inputs are different. And we look, and 1, all the inputs are different. So that's a function. 2, all the inputs are different. Function. 3, the inputs are not all different, but look at the outputs. The outputs are the same, so that's still a function because every input only has one output. And then finally, we look at 4. Those two inputs are the same, but their outputs are different, so that one cannot be a function. So which ones represent functions? Well, that's going to be 1, 2, and 3. Number 4, use the graph, plot a point so that the resulting relation is a function. Well, I just need to plot a point anywhere that's not on top of one of these other points. So I could put a point here, it's still a function. Put a point here, it's still a function. Put a point here, here. Any of those would be valid points. For the sake of this, I'm just going to pick one of those. I'm going to pick this guy right here. And my domain, this is a discrete function. Remember, we use the braces. And my domain is the possible x value. So I've got -3, -2.5, -1.5, -0.5, +0.5, and 1.5. Those are my inputs, and then my range of the outputs, I'm going to take all the y values. And it looks like those are 1, 1.5, 2, 2.5, and 3. And then part C, use the function right in ordered pairs so that the resulting relation is not a function. So we need to make this not pass the vertical line test. Well, the easiest thing to do is just take one of my points that already exist, put another dot right above it, right below it, anywhere on any of those dots. So I could put a dot here, one way down here, and all those points will not pass the vertical line test. And all I have to do is pick one of those and write the ordered pair. I'm going to use the purple one that I made at the beginning, which is 1.5, comma 2.5. All right, let's look at the next problem, number 5. So Sergio has 22 sports drinks for his birthday party. He's planning on buying some 12 packs if needed. Sergio is not sure yet about the number of 12 packs he needs to buy, but he has enough to buy 6. Write a function to describe how many Sergio can buy. Let x represent the number of 12 packs. So he already has 22 sports drinks. So we want to know how many drinks he can buy. So drinks are equal to so this problem, it's not worded very clearly. So x is the number of 12 packs. So if he buys one 12 pack, that's actually 12 sodas. So he already has 22 sodas, plus he's adding 12 more sodas per 12 pack. So the number of drinks he can buy total is equal to 22 plus 12x. And then the domain is going to be, it's going to be discrete, because he can't buy half of a 12 pack. He can buy 0 more, 1 more, 2 more, 3 more, 4 more, 5 more, or 6 more 12 packs. And then part C, find the range of this function. So the range is going to be what happens when he buys each of those 12 packs. So the range, if he buys 0, he has 22 sodas. If he buys 1, he's got 34. If he buys 2, he's got 46. So I'm just adding 12 each time. 58 for 3, 70 for 4, 82 for 5, and 94 if he buys all 6 of them. Number 6, the function f of x equals 5x describes how far from home Sandra is as she drives from Phoenix to Tucson. Draw a graph that represents the function and label the axes. So it's 50x. So if it's 50x, we know that m is 50 over 1 and b is 0. So she's going to start down here in the corner. And just so we can spread it out a little bit, I'm going to skip, and every other line is going to be worth 10. So I've got 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours, 8 hours, 9 hours, 10 hours. Actually, I'm going to change my outputs. Since we know the slope is 50, it means every time we go up 50, we're going over 1 hour. So I'm just going to go ahead and count these as 50. So 50, 100, 150, 200, 250, 300, 350, 400, 450, and 500. So she starts at 0. In 1 hour, she's 50 miles. 2 hours, she's 100. 3 hours, she's 150. And it is a continuous graph. So it's going to look like that. Well, our scale could be different, obviously, but we just need to make sure that our slope is 50 over 1. All right, 7. Use the graph from that problem. Estimate how far Sandra is in 1.5 hours. So if I go to 1.5 hours, which is right here, I go up, and it looks like she's about, let's see, if I skipped a line to get 50. Each of these is 25. So she is 75 miles from home. Number 8. The function h of x equals 5x minus 9. Show that 516 lies on the graph. So if that's 516, it's x and y. All I have to do is show the x, y. When I plug those in, I get what I'm supposed to get. So this is saying h of 5 equals 5x minus 9, and that should equal 16 if we do our math right. So 5 times 5 minus 9 is 25 minus 9, and 25 minus 9 is 16. So 516 is on the line of h of x. Part B, show that 6,3 is not on the graph. Once again, it's x and y. So I'm going to plug that in. I'm going to show that h of 6 is not 3. So h of 6 is equal to 5 times 3 minus 9. So it's 15 minus 9, which is 6. 3 is not equal to 6. So 6,3 is not on h of x. Number 9. Given the graph, how many solutions does this equation have? Well, it's a line, and every point that is on the line is a solution. So just these right here that I'm drawing, these are all solutions. But we know that those arrows tell us that the graph extends in either direction forever. So any line has exactly an infinite number of solutions. State one possible solution that satisfies the function. Well, all that means is find an ordered pair that's on the line. Find an xy pair that's on the line. So if I take that point right there, that would be the point 0, 4. And that is on the function. And it says prove your solution above is a solution. Well, the only way to do that would be to find the equation of this line. So it has a b value of 4. It has a slope of, it looks like, negative 2 over 3. So the function itself is negative 2 over 3x plus 4. So if I check f of 0, it's going to be negative 2/3 times 0 plus 4. So f of 0 is 4, which is the point 0,4. Number 10, graph the line, describe the equation, and identify the x and the y intercepts. Well, the easiest thing is to actually do this backwards. The easiest way is to find the x-intercept and find the y-intercept. First, remember, if it's an x-intercept, y has to be 0, and if it's a y-intercept, x has to be 0. So if I want the x-intercept, I'm going to say negative 4x plus 2 times 0 equals 12. That cancels out. So negative 4x is equal to 12 divided by negative 4. X is equal to negative 3. So I've got a point at negative 3, 0. And my y-intercept, same thing, but this time I'm going to plug in 0 for x. So negative 4 times 0 plus 2y equals 12. That's gone. 2y equals 12, divide everything by 2, y equals 6. So we get the point 0, 6, which is just off the graph here, which gives me the line like that. All right, number 11. Daisy's Cafe has a special all-you-can-eat pancake for $8.50 per person. Tanya writes the function 850p to represent the total amount of money she will pay as a function of p. Tanya made a graph and it's shown below. Explain why the graph is not correct. Well, why is the graph not correct? What's wrong with this graph? Is the function wrong? So if f of p equals 8.50p, the slope is 8.5, so it's 8.5 over 1, and b should be 0. Well, if we look at this, we start at 0. It looks like we're going up 2, 4, 6, 8.5 over 1, so that looks okay. So what's wrong with the graph then? Well, the only thing that it could be, we shouldn't have this line here. This line means that we can pay for half of a person, or we can pay for 2.6 people, or we can pay for 3.1 people. We can't do that. So explain why the graph is not correct. It should be discrete, not continuous. And make a correct graph. Well, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So the correct graph would look very similar, but for one person she pays $8.50. Then 2 people, she's going to pay $17, and there shouldn't be anything in between those two. And then 3 people would be the next value, and 0 people is down here. So there's my correct discrete graph. And then complete the following using your correct domain. Well, let's see. So domain is possible inputs. So she could pay for 0 people, 1 person, 2 people, 3. It doesn't tell us how many people are going. So we could just put little dots to say it could go on forever. The range would then be, well, it would cost $0 for 0 people, $8.50 for 1, $17 for 2, $25.50 for 3, and again keep going. And then the rate of change is $8.50 per person. The units are important. Make sure we have those on there. Number 12, Don opened a savings with $300. Each month he will add $50 to the account. Y is the amount of money in the account after X months. What is the equation that models this? So if Y is the amount of money in his account, he started with $300 and he adds $50 every month. So Y equals 300 plus 50x. What is the rate of change and what does it mean? Well, remember, rate of change is just another way to say slope. Our slope is 50, and it means he adds $50 every month. What is the y-intercept and what does it mean? Well, the y-intercept is 300, and that is going to be amount in the account when he started saving. 13. Big Surf and Sunsplash each charge an initial fee and an extra charge for the number of people per party. Their pricing is shown as a graph or a table. So it's an initial fee. That's going to be a constant. So that's just some value that they're starting at. And we can see from the graph that Big Surf starts at 100. So Big Surf, the fee is $100, and it looks like for every person, so one person, they pay $120. So the extra charge is $20 per person. Sunsplash, on the other hand, if no people go, you're still paying $50. So that means that Sunsplash, the fee is 50. And let's see what the charge is. Well, the charge is going to be like the slope. So my cost went from 50 to 140. So that's a change of 90. And the number of people went from 0 to 3. So that's a change of 3. So if it's 90 over 3, $90 for 3 people, that's going to be $30 per person. So it looks like we have everything that we might need for this problem. Let's look at what it's asking us. Which company has the higher initial fee? Well, Big Surf charged 100. Sunsplash charged 50. So Big Surf charged 100 and Sunsplash charged 50. Which company's rate per person is higher? Well, the rate per person, that's the extra charge. Big Surf charges $20 per person. Sunsplash charges $30 per person. So Sunsplash charged $10 extra per person. Than Big Surf. Alright, we're on to the next page. Which transformations from the graph of a function f of x describes the graph of 3 times f of x? Put a little dot there. So remember we talked about in class that no matter what the function, so let's just use like an absolute value function because it's a good representation of what's going on. So there's only a handful of things that are going to happen. We discussed that a changes the slope, and if it goes from positive to negative, it's also going to reflect. H shifts horizontally or side to side, and K is a shift vertically. So if I look at this and it's 3 times f of x, well, that 3 is the same as an a. So it didn't shift up, down, left, or right. It only got steeper or flatter, and it either stretched or it compressed. So when a gets bigger, when my slope goes from 1 to 2, or 1 to 3, or 1 to 4, or even -1 to -2, or -1 to -3, remember we don't care about the negative sign. It's just the absolute value of the slope. When it gets larger, we're getting steeper. So if a went from 1, so it's 1 times f of x, to now 3 times f of x, our graph got steeper. Which also means, the other way we can say it is that it also was vertically stretched by a factor of 3. And we look at number 15, same idea, select all that apply. So I've got two things. I've got a negative in front of there. That's like a -1 times f of x plus 12. So I've got an a, and this is my k. Well, the k is going to be the easy part. That's just plus 12, and we know that k shifts it vertically. So shift up 12 units. Is there anything that, yep, vertically shift up 12 units. And then this -1. So it didn't get steeper or flatter because it's still just a 1. It was 1, it's still 1 when we look at the absolute value. But the negative tells me that it's reflecting over the x-axis. It doesn't always flip over the x-axis, but it flips over some horizontal line. And that's going to be that. So it does not get steeper, it does not get flatter, it doesn't shift down, doesn't shift left, doesn't shift right, it's not stretched, it's not reflected across the y-axis, but it is reflected across the x-axis. Technically not the x-axis because that graph, let's see, f of x might look like that, negative f of x plus 12 might look like that. 16. How would you describe the function? How would the graph of the function f(x) equals negative 2x plus 4 be affected if the function were changed to f of x equals 3x minus 6? So we got to look at a lot of stuff. So there's three things that are happening. A changes from negative to positive. A also changes from 2 to 3, and K changes from 4 to negative 6. So each of those things separately. So if we go from negative to positive, the graph is reflecting. I'm not going to say where it's reflecting. We don't need to worry about that yet. It's just we know it's reflecting because it changed from negative to positive just like the previous one. Then the slope changed from 2 to 3, so it's stretched. Vertical stretch. And finally, the K value went from 4 to negative 6. Well, K moves me up and down. So we're going to shift down, because we went from positive 4 to negative 6. Shift down 10 units. Moving on to 17, given the absolute value, graph the function below. So remember, to graph an absolute value function, we want A, which in this case is 3 over 1, and we want that HK vertex, which in this case, that's like saying 3 times the absolute value of x plus 0 minus 5. My vertex is going to be at 0, negative 5, which is here. And then my slope with A, we always do the positive side is the right side. Up 3 over 1, up 3 over 1, and then we go back to the vertex and go up 3 left 1, up 3 left 1, and we get a graph, an absolute value graph. That looks like that. And then we need to identify the vertex. Well, we already did. The vertex is at 0, negative 5. And moving on to the last problem. Baseball player started his career in the minor leagues. As he moved to the major leagues, his salary increased. Sadly, he got older. As he got older, his salary decreased. The equation S equals negative 4 times the absolute value of T minus 5 plus 6, where S is a salary in hundreds of thousands and T is time in weeks. What is the maximum salary he received during his career? Well, that's easy. Because this is an absolute value function, we know that it's either going to look like that, or it's going to look like that. When A is negative, it's upside down. When A is positive, it's right side up. In this case, A is negative, so we have this graph right here. And when we look at that graph, the maximum, the largest value we're ever going to reach is here, which is at the point that we already know how to find H and K. Well, where is that at? Maximum salary is going to happen at 5, 6. But what do those things mean? Which one is his salary? Well, T is time. So that is weeks. And 6 is the salary. So we know his maximum salary is 6, but it told us that it's 6 in hundreds of thousands. So he has a max salary of $600,000 over his career. When did he receive his maximum salary? Well, we know when that happens. That happens in 5 weeks, which seems a little quick, but that's the problem we were given. So all we had to do for that one was find the maximum of the graph, figure out what it meant, and we're all set. And that's the end of our review for Unit 2.